Welcome to our session. So today we will be discussing how to solve our quiz yesterday. So this is principles of steel design, and this is the topic analysis of tension members. So we have here a given L section, L6 by 4 by 3 fourths, and we are asked to calculate the maximum acceptable tensile service load ano. So when you think about this problem, pag sinabi maximum acceptable tensile service load, you must be able to identify na ang unknown natin is actually the value of the dead load and the live load. Okay, so we need to get the value of those two. And then given yung leg natin, and then we have a 7-inch diameter bolts, assume no stagger, and then all bolts participate in carrying the load. It means na not di naman ibig sabihin na sa during rupture lahat ito is kailangan mag-rupture, no? It's just mean na each bolt will be receiving equal um, equal share dun sa loading natin mismo. Okay, and then the live load is 3 times the dead load. And then we have that type of steel. So we have again an L 6 by 4 by 3 fourths. Okay, and then we have a 7/8 diameter bolt. Okay, so diameter of our bolt is 7/8 inches. So pwede natin kunin yung effective hole diameter natin. That is just dB plus 1/8 for our English. So that is 7/8 plus 1/8, or ang ating effective diameter is 1.0 inch. Alright? And then we are also given with our type of steel. That is A572 grade 50. So that is Fy is equals to 50 KSI. And then Fu is 65 KSI. Right? And then to get the value of our dead load and live load, we need to get the capacity of our section. And based from our discussion so far, we have two limit state to consider, which is GSY and NSR. Okay, but to get the load, let's say we need to get the allowable load, is PA, using our load combination. That is just equals to dead load plus live load. But as mentioned here, the live load is 3 times our dead load. It means that we can actually substitute 3D here. So our allowable load is 4D. So let us consider this as equation number 1. Okay, and then we can now get the nominal capacity of our section. That is for ASDPN over omega. So first, using gross section yielding, for gross section yielding, that is Pn over omega, that is Fy times Ag all over 1.67. So we need the property of our section. So looking at our section, that is 6 by 4 by 3 fourths, let us go dun sa L shape natin. Okay, so this is our L shape. So we need 6 by 4. 6 by 4 by 3 fourths. So it's highlighted here already. So 6 by 4 by 3 fourths. Area niya is 6.94, as you can see. Okay. So 6.94. Area gross is 6.94 inches squared. Okay. So we can calculate now our section. So 50 KSI kip per inches squared. 6.94 inches squared over 1.67. Pn over omega, according to gross section yielding, will be 50 times 6.94 all over 1.67. That is 207.784 tips. So that is our initial capacity for cross section yielding. Okay. Next, let's calculate the capacity for net section rupture. So let us just move this here. Okay, net section rupture. Okay, for NSR, upper B, our capacity is Pn per omega, that is equals to Fu AE over 2.0. But we don't know yet the value. If net area natin is U times AN, wherein AN is equals to AG minus the number of bolts when during rupture, the effective diameter of hole and thickness of our connected member. So AG we do have that is 6.94 inches squared minus the number of bolt when it ruptures. No? So since our type of connection is a grid type connection, you just need to assume that you're standing over here, you are holding a flashlight, and then you try to point your flashlight dun sa members natin or dun sa bolts natin. Whatever is yung bolt na illuminate first, that is actually the bolt wherein mag-aano yung ating rapture, magpa-pass through or possible location ng ating rapture. So again, it means na ito yung possible na mismong dadaanan ng rupture natin, ano, this bolt. And ang number of bolts niyan ay dalawa, no? 2 bolts. We have 2 bolts and then our effective diameter that is 1 inch as we calculated earlier. And then the thickness of our section, since this is an angle bar, this is the thickness, ano? So 3/4. AN is equals to 6.94 minus 2 times 1 times 0.75, that is 5.44. This is for our net area. So next is our shear lag factor. Okay, and according to our D3 table D3.1, ito yung D3.1. Since our member is connected into one leg, we cannot use case 1. So therefore, automatic, we will be using case 2. And then other cases applicable is case 8 for angles. Okay? And ang condition natin, we have 3 fasteners per direction. So ito yung other value of our U. No? And as mentioned here, if ever we use the as per case 2, whichever is larger between case 8 and case 2 will govern. Okay, so starting off with case 2. So case 2 natin is 1 minus bar X connection over L code. Okay, bar X connection is from whichever is the connected face, tapos distance pupunta sa centroid natin. Okay, and ang connected leg natin is yung longer leg, ano? So yung sa L shape natin, so you can see in this diagram, ito yung longer leg, ito yung shorter leg. So yung longer leg ito, and then yung centroid is ito. Whatever is that distance, that will is our x-con. So for this case, x-con natin is yung bar x value natin. So let's get the value of bar x. That is 1.07. Okay, so substituting that value here, 1 minus 1.07 inch over our L-con. L-con is the center to center distance of out to out bolt. So this is the farthest bolt on the left and then to the right. In total niyan, which is just the sum of this. That is 7.0 inch. So U2 is 1 minus 1.07 over 7. This is 0.847. Okay. And then for case 8, again, yun natin, yung condition natin is 0.6. So whichever is larger, siya mag-govern. So ito yung mag-govern. So therefore, U natin is equals to 0.847. Okay, so now we can calculate our VP, our value. So that is 65 KSI times AE natin, that is 0.847 multiplied by 5.44 inches squared all over 2.0 rather. Okay, so Pn over omega is 65 times 0.847 times 5.44 divide 2, that is 149.750 kips. Okay, and for us to determine whichever is critical, doon sa dalawang ano natin, whichever is smaller, so this is the governing one. Ibig sabihin, ang ating capacity of our section is 149.75 kips. Okay, so now we can now use this value to equate our allowable para malaman natin yung value of our D. Okay, so PA natin is 4D is equals to 149.75 kips. So D natin is equals to 149.75 divide 4, that is 37.44 kips. And then for live load, that is times 3 of that value, that is 112. So 112.32 kip. Okay, so whichever is given dun sa multiple choice kung meron man. So this can be your answer, or this can be your answer for the maximum service load. Okay, so that's how you calculate this problem.